So we have done, like I know you're doing exponents, but we did do, I don't know if you remember it, but exponential functions, okay? Here's a quick recap. Exponential functions, it's going to look something like this. This is your grid. It's going to go up. It's going to be in this form, ax plus b. This one is probably looks like it could be anything, but this looks like it's y equals 2 to the power of x. They have an invisible wall on the x-axis, well, the base functions anyways. Like this function will never be 0 on the y. It's going to try and get to 0, but it'll never be 0. It's going to go infinitely, like indefinitely forever. It can be like 0.0001, and then maybe 10,000 zeros, and then 1, but it'll never be exactly 0, okay? Those are exponential functions. I guess we could just quickly do these guys. And I'm going to introduce you to something that we've never done, which you may like, or which also you may not like. Alrighty, let's try doing E. What do you think we do first?
You open the bracket?
Right. So just remember this, you see this negative d to the 4. It's not saying negative d to the 4, okay? This one. What that actually means is like you can rewrite that as -1 times d to the 4, and then times we can open up the other bracket, c squared over d squared. Now what? Are there any like terms that we can kind of cancel out or like group them up or something? No?
The D's?
Right, so what would we get? What's going to be the final answer here? What's d4 over d2? If you simplify these two?
You get D squared?
Yeah, and that's it, right? You have -1 d squared c squared, and that's the final answer. Easy as that. Any issues here? No, right? You shouldn't be having issues with this one. This is a very basic one. F is also very, very similar. We know if we have double exponents, we would multiply them using the third rule, the power rule. But now we have triple exponents. It doesn't change anything. You just multiply all 3 of the exponents. Like that. 3 and 3 gone. -1 times -1 is just 1. Final answer, x to the power of 1. We'll come back to this graphing stuff later. I want to do the algebraic portions. All right, so we did exponentials. Now there's an opposite. There's an opposite of everything. Well, by opposite, I mean the inverse. Okay, every function has an inverse. For example, let's start with a very basic one. Y equals 3x plus 2. Okay, this is our straight line, has a slope 3, y-intercept 2. The question is, what is y inverse? See that y to the power of -1? That means y inverse. And it's going to be, well, in this case, it's going to be a function. And to find y inverse, there's 2 things you need to do. It's pretty simple, actually. Step 1, you're going to change the x into a y, and you're going to change the y's into an x, okay? This is called interchanging variables. X becomes y, but then y becomes x. So in this case, y becomes x. So we're going to rewrite this as x equals 3y plus 2. See that? That's step 1. Y becomes x, x becomes y. Step 2 is now you solve for this new y. After you change it, you're going to end up with a y somewhere. We're going to solve for this y. Look at this equation. It's a linear equation. How do we solve for this? We want to isolate y.
You subtract 2 and divide by 3.
Exactly, x minus 2 divided by 3, and there we go. This is y inverse. And that's it. What does it actually mean? Well, if you look at some points of y, right, this is y, and then we're going to compare it with some points of y inverse. So 3x plus 2, when x is 0, y would be 2, right? What about when x is 1? What would y be?
It'll be 5.
It'll be 5, right? What about 2? Well, it's just going to go up by 3 each time, so it's going to be 8. If it's negative 1, it would be negative 1. You see that? Now we're going to make a table for y inverse. Y inverse has this equation, x minus 2 over 3, right? Let's say x is 8. What would y be?
It'll be 2.
It'll be 2, that's right. Let's say y is 5. Sorry, when x is 5. When x is 5, what would y inverse be?
1.
1, right? You notice the pattern? What about when x is 2? What would y be?
1.
2 would be 0, right? 0. Y inverse
Oh,
would be 0. You see that? Now let's compare. Let's look at these guys. You see 0, 2 we had for y. Y inverse becomes 2, 0. The x and the y's, they flip. You see, like we said here? And this is going to happen with every point. 2, 8, we had it for y. And y inverse, it became 8 and 2, right? Like negative 1, we know for a fact this is going to become, well, if you flip it, still negative 1, negative 1. Let's check. When x is negative 1, you get negative 1 minus 2 over 3. Negative 3 over 3, that's going to be negative 1. There we go. And 1, 5 becomes 5, 1. Yeah? So basically, all the x's and y's, they swap. That's the table way of looking at it. Algebraically, x and y swap the variables. In the tables, their actual values swap. There's one last way of looking at inverses, which is the graphical way, and which is going to be very helpful when we do the next thing that we're about to do. So let's say this is a grid, yeah? Let's say this is some function y, yes? Graphically, what happens is we're going to draw a diagonal line on the xy plane, like that. It's basically a mirror. We're going to introduce a new axis, x-axis, y-axis. But now we have a new axis, and this axis has the equation y equals x. This angle here is going to be 45. It cuts the first quadrant exactly in half, okay? And what we do is we're going to flip our y on this axis, and we get y inverse. If you flip it, if you can see it, right, it's kind of tricky to see, but it's not that difficult. There you go. Approximately. This is the graph of y inverse. You flip it on that line. Use it as a mirror, okay? Like another example would be something like this, right? Let's say we have something like this. We're going to flip it onto this y equals x axis, and then we get what? What does it look like? Would it look like, I give you two options. Would it look like A, or would it look like B? We're flipping it on this line.
It'll look like B.
That's absolutely right, because A never crossed the x-axis, right? This guy, our original function never crossed the x-axis. That means our inverse function will never cross the y-axis. Okay, so it'll look like B. And this has a name. Let's say this one, our exponential function, we can call this y equals 10 to the power of x. It's some exponential function with a base of 10, yeah? Now, what in the world is its inverse? Turns out this B, graph B, this is something called a logarithmic function. logarithmic function. If you have a calculator, there should be a button called log, log. And that's what b is. B is y equals log of x. Okay, what is a log? Well, it's just the inverse of an exponential function. You see that?
Mm-hmm.
It's something new. Yeah, it's something new. Now the next thing would be to go from we know these are inverses, right? But we need to be able to change exponential into a log function. Why do we do this? To solve exponential equations. For example, let's do a quick example. 2x equals 4. Yeah? How
Mm-hmm.
do we solve this exponential equation for x? Any ideas whatsoever? You're gonna
We
want to
use
write,
the log function.
you could do that, but you don't have to. 2x equals 2 squared. 4 is 2 squared, yeah? And
Mm-hmm.
if they have the same basis, the bases cancel out, x is 2. And that makes sense because 2 squared is 4. That means x must have been
Uh-huh.
2. Right, same idea here. Like, let's say 3x equals 27. How do we do this? Using the same idea. What is 27 in terms of 3?
It's 3 times 3 times 3.
So it's 3 cubed, right?
Uh-huh.
So this, bada boom, bada bam, gone. X is 3. Easy. But what if we had something like this? 2x equals to 3. Now there is no way we can write 3 in terms of 2, right? So if you end up with something like this, you need to use the log function to answer this question, okay?
Mm-hmm.
Let's try doing some examples. We're gonna start off with a simple one. Looks weird, I know. It's something new, right? It's something new. So this is the format, okay? Let's say you have a log of some base b of some number a, like here b is 4, a 64. This entire thing is gonna evaluate to some number c, okay? The answer to this is
Mm-hmm.
gonna be a constant. Well, in this case, it's gonna be a 3, but I'll show you why that is. So the goal is to flip this logarithmic equation into an exponential equation, because then we can work with it. It's easier. So how do you flip it? Well, look at the formula here. Log b of a equals c becomes b to the power of c equals a. Okay,
Mm-hmm.
that's the formula. Using this logic, let's say this entire thing is equals to some number c. Okay, now look at this. If we change this into an exponential equation, it's going to become 4 to the power of c equals 64. Do you see that?
Mm-hmm.
Now, what's 64 in terms of 4? 4 power what? Is it 2, 3, or 4? 4 to the power of something is 64.
3.
Yeah. Now notice the bases are the same. Cancels out, c is 3. That's how you solve this or evaluate this, okay?
Okay.
Let's do another one. Oh, this one's a trick question. This one is a trick question. Same idea though, same idea. But I'm telling you it's a trick question. So let's say this is c, right? How do you write this in exponential form? I want to write it in this form.
2 to the power of c equals -4.
Right. Now what's -4 in terms of 2? Can you write
Um,
-4 in terms of 2? What about 2 to the power -2? Is that -4?
that gives you a positive.
Yeah, it gives you a positive number, right? Is there any way we can write -4 in terms of 2? Powers of 2?
No.
No, we can't, right? So this one, C doesn't have an answer. There is no answer to this question. In fact, here's the rule. If you have log, doesn't matter what the base is, this number in here, the A value, must be greater than 0. This bracket here must be greater than 0. Let's say this was exactly 0. Nothing would watch. There's still no answer here. Well, let's say we had log base 2 of 0 equals C, right? Then you have 2 to the C equals 0. What's 0 in terms of 2? Nothing. It just doesn't exist. You can't write 2 to the power of something and this will ever give you 0, right?
Mhm.
So this is unsolvable, which brings us to the domain of a log function. Let's say you have some log b of a. You see this a? This a has to be strictly positive. Cannot be 0, cannot be negative. Only then you can evaluate this. Otherwise, you can't do it.
Okay.
That's called a domain. Domain means the possible x values. It's not always going to be with numbers, right? It could be with like log base 2 of x. The domain of x is x has to be strictly positive. Can't be 0 either. You getting this? It's fun, right?
I guess.
Don't you want to do this every weekend? Do some random maths. In fact, the number of topics we've covered is, I don't know, go look back at the videos. Like we're like all over the place. But it's kind of good because math doesn't only have like one topic, right? So we've basically
Mhm.
we jumped from here to here and then come back, and then it's good though. And a lot of them are interlinked, right? Like this unit is the same thing you're doing in school. It's exponents. Now let's rewrite this in exponential form. It's gonna be 3, the base to the power of c equals 1 over 27. What do we do now? This one does have an answer because that number is positive. Can we write 1 over 27 as 3 to the power something? Or what about 27 by itself? Can we write that as 3 to the power something? Nope. Yes, I guess it's just flip a coin. It's a yes or no question, I guess. 27 in terms of 3, is that possible?
3 to the power of 3.
Right. So now think about it. This becomes 1 over 27 is 1 over 3 to the power of 3. But the other side, we have 3 in the numerator. So that means from this side, we need the 3 in the numerator. We toss it upstairs. What does that become? If you throw that 3 power 3 from the denominator into the numerator, what does it become?
Does it become a negative?
Yeah, it's going to become a negative. It's going to become 3 to the power c is equals to 3 to the power -3. Okay?
Okay.
Do you understand why it became negative? Because we tossed it upstairs. Why did we toss it upstairs? Because on the left side, we have it in the numerator. That's why. In order for these bases to cancel out, you need them in the same position. And then therefore the answer is C is -3. So this entire thing is equals to -3. Cool?
Uh-huh.
Again, all these you can evaluate because the thing in here, the A value is a positive number. So again, we're going to let this be some number C. So we have 5 to the power C is equals to cube root of square root of 25. Now we need to write this entire thing as 5 to the power something. What do you think? What about square root of 25? How do you write this in terms of 5 to the power?
5
Or
squared.
5 squared, right? So cube root of 25 becomes cube root of 5 squared. And what did I tell you last time? This exponent that's on the radical, where does it go? If you want to write this in exponential form, goes in the denominator.
Okay.
Okay, you see that? Kind of tricky, but just exponent laws, right? Radical to exponential. The radical is going to go in the denominator. And from here, 5 and 5, bada boom, gone. C's 2/3. Good?
Uh-huh.
Is it difficult?
No.
Tell me, 36 to the power 7. I need this in terms of something to the power something. What is it?
6 to the power of 2 over 7.
Yeah, that's it. Perfect. It's not that difficult. Hmm. All right, this one we're gonna hit a brick wall because, so let's say this is some number C, then you have 5 to the power C equals 47. You agree with that?
Uh-huh.
Now the issue here is that we can't write 47 in terms of 5. So what we're gonna do is we're gonna just guess the answer. And don't worry, we don't like to guess in maths, but this question, it just says the approximate value. That's why. 47 is in between 5 squared and 5 cubed, right?
Mm-hmm.
Because 5 squared is 25. 5 cubed, again, you can't go 1 or 4 doesn't help us. 2 and 3 does though. Because 47 is in between these two. Which one is it closer to? 25 or 125? Or is it right in the middle?
25.
It's definitely closer to 25. If it was right in the middle, the answer would have been something like 5 to the 2.5, right? Again, this is just an estimate, don't worry. I'm going to tell you exactly how to find this, but for now, you need to understand this logic as well. So we know it's not exactly in the middle, right? The middle will be 2.5. It's a little bit closer to this side, yeah? So we can just make it something like 2.2 and C is 2.2, approximately.
Mm-hmm.
But that's not the technical answer here. Let me show you how to do the technical answer as well, because we don't like to guess. Step 1, you're going to rewrite this in exponential form. Step 2, we're going to take logs on both sides. Check this out. Log of 5 to the power C equals log of 47. What's next? If you remember, we have done something like this, but it may have been a while ago. It's okay if you don't remember. So log has this very special property. If you have log of a to the power of k, this k exponent guy, you can bring it out front. So here,
Mm-hmm.
the c exponent thing, we're going to bring it out front on the same level. C times log 5 is log 47, okay? So therefore, C on a calculator is going to be log 47 divided by log 5. Type that in if you have a calculator.
It says 2.392.
Yeah, there we go. That's the exact answer. We said 2.2. I guess we weren't that far off, but that's how you'd find the exact answer, okay?
Mm-hmm.
Now we could do the X approach, right? But you also want to think of it this way. So or C approach, whatever. CX. This letter is, you can call it whatever you want. 6 to the power something is 1. What is that number? 6 to the power something is 1. What is this?
To the power of 0.
Yeah, exactly. So log 6 of 1 is straight up 0. See that? Same idea here. 5 to the power something is 5 to the power of x. What's this box?
1.
No, it's x. Right? 5 to the x is 5 to the x.
Mm-hmm.
So that thing there, the entire thing just becomes an x. In fact, log 5 and 5 to the power of x, they're inverse functions of one another. You can cancel them out. Same thing with this one. 6 is an exponential function because we have in the power of something. And then log 6 is the inverse function. So they eat each other. It's going to be x as well. If you want the notation, let's say we have f of x, and then we have f inverse of x. The f of f inverse of x is going to be x. Same thing the other way around. F inverse of f of x is going to be an x. They're gonna eat each other. Okay? They cancel
Okay.
out. Yeah, eat each other is like Winnie the Pooh story, but they're gonna yeah, they're gonna cancel each other out. Here, let's do let's do a little bit more difficult inverse question. Let's start off with a difficult linear. Well, it's not that difficult, but we're trying to find the inverse of this linear function. What are the steps? Remember we did this before? Well, you interchange x and y, yeah?
Mm-hmm.
X becomes y. This is always the first thing you do when you solve for inverse. So this becomes x, 2 over 3y minus 6. Now the goal is to solve for this new y. What do we do on both sides?
You add 6.
What's next?
You divide by 2 over 3.
Okay, so we're doing x plus 6 divided by 2 over 3, right? If I flip this sign, what
Mm-hmm.
does it become? The division sign, we're going to flip it into a multiplication. You got to flip the other term, right? So we
Uh-huh.
get x plus 6 times 3 over 2 is y. If I open this bracket, what do I get? Just FOIL it.
Is it
No,
just x plus 18 over 2?
no, there's a bracket. This 3 applies to both x and 6. It's going to be 3x plus 18 over 2. And you're done. Cool?
Okay.
So that's the inverse of a linear function. What if I gave you a quadratic function? What's the first step? Doesn't matter what function it is. The first step is always the same, which is,
You switch x and y.
yeah, you flip x and y. So x equals 3, y plus 4 squared minus 6. What's next?
Do you open the bracket first?
Here's the thing, you do not want to open the bracket because if you open a bracket, you'll get y squared and you'll also get a y. So now you have a quadratic function and a linear function that you need to work with. Makes things a little bit more difficult. Don't open the bracket. So here, the next thing to do is to add 6 on both sides. Okay?
Uh-huh.
What do you think next thing is? Do not open the brackets. We will never open this bracket. So we can only
Divide by
do
3.
divide by 3, right? So now this is gone. What do you think is next? We don't want to open the brackets.
Use square root.
Yes. So if we square root it, from this side, this 2 cancels out. You get y plus 4. What do we get on the other side if we square root it? Well, you'll simply get the square root of that, right? Like that.
Mm-hmm.
But the funny thing is, the square root of anything is going to be plus minus. Okay?
Mm-hmm.
Square root of anything is plus minus. And then finally, we would subtract a 4. And that's going to be the inverse of this quadratic function. There we go. It's a little bit tricky. If you want to visualize it, it's even more difficult. This one has a vertex at -4, -6. So this is a quadratic function, right? So it had a vertex at -4, -6. That means this inverse function will have a vertex at -6, -4. So -6 right there. And then it's gonna go, if you flip it on this line, it's gonna be kind of hard to see, but if you were to flip it, you would get something like this. There you go. That's the inverse of a quadratic function. Turns out the inverse of a quadratic function is not actually a function because it's going sideways and more importantly, because it fails the vertical line test. The vertical line test means for any x values, if there's 2 different y values like it is here, then it's not a function. So this thing in blue, this thing that we found, the inverse of the quadratic is not a function. Okay?
Okay.
It's not a function. Okay, what if we want to find the inverse of a exponential function? Again, we do same thing that we do, right? Like that. Flip x and y. And now we want to solve for this y. What do you think we do on both sides? You want to take logs, okay? Look at this. The log of x equals log 3 to the power of y. Why are we taking logs? Well, it's because we are allowed to bring the y down. So it becomes y times log 3 equals log x. So therefore, y is going to be log x over log 3. You see that?
Mm-hmm.
And when you have multiple logs, when you're dividing something actually, you can rewrite this as one big log. Log of base 3 of x. And there we go. That's the inverse of 3 to the power of x. Graphically, 3 to the power of x looks like this, and log 3 to the power of x looks like this. They're inverses of one another. Cool?
Mm-hmm.
Yeah, what do I mean by this final line? So if you have log 5, it only works when it's divided, okay? Log 5 divided by log 2, it's going to be log base 2 of 5. You can work backwards, you can work for this direction as well. So if you have multiple logs, you can combine them. So far, so good?
Mm-hmm.
Let's just do a bunch of these, like They're all gonna be one-step answers, by the way. And here's the rule, right? So if you have a to the power of b equals c, or what did we call it before? We called it log of base b, a equals c. This is the same thing as saying b to the power of c equals a, okay?
Mm-hmm.
So we can go in this direction, but we can also work backwards. Here they're asking us to work backwards. They've given this in terms of an exponential equation. We need to rewrite it as a log equation. You see this thing that's being taken to a power? That is going to be
Mm-hmm.
your base, okay? And the
Okay.
power, the exponent goes on the right side, and what's equals to is your a, like that.
Mm-hmm.
Look at b. This base 3 is going to be our base. Base stays as the base. And what's on the other side comes here as a, and then your power goes to the other side. Okay, same thing here. 0 is going to go to the other side, log base 8 of 1. Can you tell me for d?
Um, log 6 and then 1 over 36 equals -2.
That's right, absolutely right. And that's all there is to this. E, it's going to be log. Again, the base becomes the base, 1 over 3. The exponent gets tossed on the other side, and the other side becomes the a value like that. What's the answer to F?
Log 8 and then 2 equals 1 over 3.
That's it. That is it. Now, if they give you in log form, it's even easier, I think. You literally do the same thing, but now you work forwards. Here, let me do the first few. For A, it's gonna be 2. Again, you can follow the formula there. The base becomes the base. The right side becomes the exponent equals 8, like that. You can always double check if you did it right. Yeah, 2 cubed is 8, so this must be true, right? For B, it's gonna be 5 to the -2 equals 1 over 25. What's the answer to C?
3 to the power of 4 equals 81.
Right, easier. And look at all these are very simple. 1/6 to the -3 is 216. What about E?
6 to the power of 1 over 2 equals 6 squared.
Yeah, square root of 6.
7.
F?
10 to the power of 0 equals 1.
Is that true?
Yes.
Yes, it is. What's -10 to the power of 0?
Is it -1?
No, anything to the power of 0 is a 1. Doesn't matter if it's positive or negative.
Okay.
What is 1 to the power of 0?
1.
What is 0 to the power of 1?
0.
Yeah. What's 0 to the power of 0?
0.
It's actually a question mark. Turns out it's a 1. But there's some debate around this. Um, actually, it doesn't equals to anything. This one, it just does not exist, okay? But approximately, it's 1. How's it 1? Well,
Like 0
yeah.
0.0001.
No. So that's what we have on the left. If you take a very small number, and then if you take a power very, very close to 0, that's 1. Or actually, it's gonna be 0.9999999.
Oh.
So which means if you use this relation, just round up a little bit, 0 to the power of 0 is 1, which is really weird. But it is what it is. And don't worry about this. This is just mumbo jumbo for us. This is more for the curiosity's sake, right? This is
Mm-hmm.
abstract math. This is, you'll never see this. Well, not for 5 years at least, I think, if you ever do see it. You'll only see it if you go into like a very math heavy course in university, which most people do not unless they're a little bit cookster. Do you know anyone who did math, like major in university, like a math degree?
I don't think so.
Yeah, most people, I know some people, but most people would rather not do that because the it doesn't leave you a lot of choices in terms of career paths by doing a major in math. You only have two options. You can either become a teacher or you can become like a research person. Math by itself is not good, but you need to pair it up, right? Like, you have a choice. You have a major, right? Like, you can do this in anything you want. And then you have something called a minor. Minor is gonna be like your secondary main courses that you'll be taking in university. So a good pair here, let me show you a good pair. Let's say you're trying to do a major in math. In terms of minor, you can do business or something. In fact, I know one pairing that's extremely popular. Major in math and minor in economics. This here is really popular. The other one is also popular. You do a major in economics and do a minor in math. This is also very popular. So that's when people do like high level math is here as a minor. But a lot of people also major in math, but that is what it is. Um Here's a completely useless math minor that doesn't help you at all. Let's say you're majoring in something like, I don't know, psychology or something. I'm sure psychology has some maths because of data gathering, but not much actually. No, this one's probably the worst. Let's say you're majoring in philosophy, then you have a minor in maths. That pair is what? Doesn't add up, right? They have nothing to do with each other. Completely different fields. Minor is something that complements your major. Okay.
Okay.
Uh, let's say you're doing architecture major. Minor, you can do visual arts or something. That's perfect. Yeah, so that's when people end up into these things because most people end up doing a minor in maths. I'm more of a like a stats person, to be honest. You know what statistics are?
I think so.
Yeah, that's what I like to do in terms of like higher level maths. Anyways, we'll do that if you want eventually. We have done something like average, I don't know, like
Mm-hmm.
average and stuff. I did this course, yeah, with your mother, I believe, the stats course. It's fun. Stats is really fun. Mm,
Did she do well?
um, yeah, she did because I taught it. I think she did. I don't know. I'm pretty sure she
I'll
did.
ask her.
Yeah, I asked her how she did in that math, in that stats course. Okay, let's go to 9A. The answer to A is straight up a 5. Why is that, right? Sometimes it's if you can see it, we have a log function here with a base 3, and then we have an exponential function here with a base 3. They're inverses of each other. They cancel each other out. Can you tell me what the answer to B is? It's the same idea, but it's in the flipped order, in the reverse order.
Is it 25?
Yeah, it's just 25. What's the answer to C? Same idea.
1 over 16?
Yeah, D is gonna be N. E is gonna be B. F, though, what's F?
Is it 1?
It's 0. Because we're looking for 1 over 10 to the power of something is equals to 1. The only thing that would fit is 0. Right? Anything to the power of 0 is a
Mm-hmm.
1. So if you see your a value here as a 1, the answer is more than likely a 0 for the entire thing. This one's a little bit trickier though, because even though there is a log function and an exponential function, they don't have the same base. So the answer here is not 1 over 3. The answer here is not 1 over 3. Okay, how do we do this? What do you think? I'll give you a hint. You need to write 16 in terms of 2, and then they will cancel out. What's 16 as a power of 2?
2 to the power of 4.
Yes, so you have log base 2, 2 to the power of 4, yeah? And then you
And
have
then
1
it's
over
4.
3. No, it's not 4. So you can combine them, right? Because 4 times 1 over 3, it's going to be 4 over 3. And now you cancel
Uh-huh.
these guys out. So the answer is 4 over 3.
Okay.
You're talking statistics. Let me show you quickly something that I was working on earlier. It may or may not inspire you. It's gonna look a little bit tricky though. You can do this with Excel, but Excel can only do so much. Eventually you'll find out, but Excel is very powerful, Microsoft Excel. But it's the issue with Excel is like it's not as fast, okay? Um Here's something that I was working with before. Let me show you this code. And this is statistics, okay? You see there's a bunch of words, right? A bunch of words, but every single line here has a point, has a meaning. We may not understand it, but the computer does understand it. So what's the point of all this, right? The point of all this is to analyze this data. If I click this button here, run button, yeah,
Mm-hmm.
see what happens. Boom. We get a bunch of cool graphs and a bunch of cool tables. See that?
Mm-hmm.
So that's kind of like stats. It's pretty cool. And eventually, a lot of it is going to be computer based because statistics is mostly used in like analyzing any sort of data for anything. But the issue with that is, here's a good example of this. Census is like it's like a countrywide survey. Okay, there's like, I don't know, 38 million Canadians. No one's going to be counting every single one of them, right? So what they do
Uh-huh.
is they use statistics to make the data more pretty. They can get vital information out of it. And it's a lot of it is automated as well. So when you file for your taxes or something, right? You basically become, well, you won't do this until you're 18, but like a lot of people that let's say you have a bunch of different like name, like income, whatever, SIN number, address, yada 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 yada. You just become a cell or a spot on the government's database. This is you, this is someone else, this is someone else. So you
Mm-hmm.
automatically go to this cell, and using software we can analyze this data. We can see, like, what's the mean income in this city or in this province, right? How much did people spend on dental and stuff like that? And
Uh-huh.
we're not doing this for like 20 people, we're doing this for millions of people, and that's why we use software. It's a relatively new field. Well, relatively new means it basically started with computers doing this
Okay.
on this massive scale. Back in the day, people would count it out by hand, brute force it, which is obviously it's very error prone. But if you do it using software, it's cool. Let's chill. Um, okay, let's look at this. Mm, Kind of a tricky question, or is it? It's not. So what is this saying? There's some bacteria, whatever. Um, so there's 40 here, yeah. Initially, there's 40, okay? This is today. You can think of it that way. Today, when time is 0, there's 40, whatever this is, mold spores. And then after 1 week, right? After 1 week, how many are there? If it grows by a factor of 10. There's going to be 400, right?
Mm-hmm.
Grows by a factor of 10. How many are there going to be after 2 weeks? Well, it's going to grow by a factor of 10 again. It's going to be 4,000. How many after 3 weeks? Notice every week,
11.
40,000, right? Every week it's being multiplied by 10, right? Like that.
Okay.
Now, what did the question want? It wants 2,000. Well, 2,000 is between 1 week and 2 weeks. It's closer to 1 week than it is. Oh, yeah, it's closer, right? Because 1,000 is here, 2,000 is here. So it's approximately in the middle. It's 1,600 away from the left side, and it's 2,000 away from the right side. 2,000, right? So we know the answer is going to be approximately 1.5 weeks, which is what, like 10 days? Yeah. But that's a guesstimate. What if it's 9 days? What if it's 11 days? We don't like guesswork here. So the trick is to convert this into an exponential equation. And I'll tell you how to do this. Um, the number of spores, okay, after t weeks is equals to the initial number of bacteria times the growth factor, in this case is 10, to the power of t. Using this formula, this is a formula you'll probably be given if you had to do this on a test. N of t is our y value, the number of bacteria, so we know our y value is 2,000. Initially, we started off with 40 and 10 to the power of t. There we go. This is our equation. This is where you need to, what you need to get. How do you solve this exponential equation for t? What do you do both on both sides? First thing,
Divide by 40.
divide by 40, and that should be, this goes with this. 200 divided by 4 is 50. Now what?
Do you use log?
Yeah, you use logs. If you can't write one, because we can't write 50 in terms of 10 to the power of something. We can write 10 times 5, but no, we're trying to write in terms of 10 to the power of something. We can't write 50 like that, so we need to take logs on both sides. So it becomes log 50 equals log 10 to the power of t. What's next? What do we do?
You bring the t down.
Yeah, so you have t times log 10 equals log 50. What's next?
You divide them.
Yeah, you divide them. What's log 50 over log 10? Our answer initially was like 1.5 weeks. That's a guesstimate. But what is this?
1.69.
Yeah, there we go. That's the exact answer. So it's gonna take 1.69 weeks for these 40 bacteria to turn into 2,000. They multiply pretty quickly. Well, they don't have a lot going on in their lives, I guess. Let's try doing an inverse question. So they want us to find the inverse of this cubic function, right? Well, not cubic, but like cube rooted. So again, step one, boom, done. Swap x and y's. Now here's the tricky bit. What do you think the next step is? We're trying to solve for that y that we have on the right side, and that'll give us y inverse. What do we do on both sides? We need to get rid of this cube root. What's the opposite of cube root? The opposite of square root is a square.
Do you just do y cubed?
Yeah, you cube both sides because a cube and the cube root are inverses. So if you cube root one side, you have to, if you cube one side, cube the other side. Therefore, y inverse is x cubed, and you're done.
Okay.
Let's try it for this. Again, step one, swap the x's and the y's. So we have x equals 0.5 to the power of y plus 2. What do we do on both sides? Trying to solve for that y up there. You take logs, okay? So it becomes log x, and then if you take logs, we know the exponent is gonna drop like that. You see that? We took the log on the right side, which allows us to bring the exponents down. Now we're gonna divide both sides by log 0.5. And then finally, we're going to subtract 2. So therefore, y inverse is, again, you see logs dividing, you can rewrite that as a base. And there we go. That's the final answer.
Mhm.
Do you understand what happened here? If you have log over log, the log on the bottom becomes the base here.
Mhm.
Okay, cool. Okay, let's call it a day there. I'll pick it up
All right.
tomorrow.
Thank you.
See ya.